Hey! Hi everyone, it's time. LiU Game Conference is back, and LiU Game Conference is on. And it's great to be back, and it's great to be here. And of course, it's equally great to see all of you here. Both you who are here in the room, and also you who are watching this from some other place. You are also with us, of course, here in the room. We are in Ebbe Park today, and well, it's no secret, I work for Ebbe Park. This is a new central city district in Linköping, and it's also the hub for the game industry in East Sweden. So right across the street, you'll find East Sweden Game. It's a community, a workplace, and also a business incubator for game studios in our region. And there you'll find people who are pushing the game industry forward every day. And yeah, LiU Game Conference is back, as I said, and we have a great day ahead of us. A lot of great content. But before we jump into the program, there are a few practicalities that I would like to go through. First of all, this is being live streamed. All the talks are live streamed, so you know that. And then we ask you, if possible, to stay seated while the speakers are up here on stage. Out of respect for them and also your friends in the audience. And then, of course, if you have to leave the room, you can. Please use the door over there in the back and be quiet. Yes. And also make sure to keep your cell phones quiet. We welcome questions, of course, and for the questions you can use menti.com, and you see the code on the screen, 81290742. Yeah. And then I will ask the questions after Samuel is done. Yeah. And my name is Linn Lichterman, and I'm here to guide you through the science track. My earliest memory of computer games is from 1985, perhaps, or maybe 86, when I was playing games on my brother's Commodore 64. And I can still recall the feeling playing these games, being drawn into alternative worlds, and well, I remember the graphic and the music and the playfulness. So retro games, they have a special place in my heart, both the old games and the newer ones. And I know that is true for many of us. So of course, there is a market for retro games. And since there's a market for those games, of course, there's also a market for a game engine that can combine that old-fashioned charm with modern technologies. And that game engine is actually being developed here in Ebbe Park right now by a game studio called Beartwigs. And with us today to share their story, we have Samuel Blomqvist. He is not only the co-founder and a developer at Beartwigs, but is also a former punk rocker from Flen. Please join me in welcoming Samuel up on the stage.
All right. See if do we have visuals? Yes.
Yeah.
Nice. Okay. Yes. So yeah, you already know my name is Samuel, and I work at Beartwigs. And this presentation is gonna go through some things. So first, we're gonna show you some stuff that we are working on, a game called Farkeep, which we are showing up there. And then we're gonna tell you like why we made the engine, and then sort of like what you need to think of when you're making a game engine yourself. And there's gonna be a lot of based on the sort of knowledge we have achieved like while developing all of this, and also from the university. All right, so Beartwigs, we are right now consists of me, Bjorn, Andreas, he's up in Skellefteå, so it's very heavily north, but we sit remote and work together. And then we have Axel, music producer, and also Magnus Shergwin jumps in now and then and makes the cool, awesome sound. So who am I? This is a really great picture of me with a fancy haircut together with Minecraft Jeb. Now I don't know why it's glitching. Okay. Well, so this was taken at Leo Game Conference 2017. I thought it was really cool, but I look like I don't know what, a buffoon. Yeah, so I come from Flen, and I moved here because we started studying at Linköping University, where we took a master's degree in computer science. And we met like a lot of cool professors who sort of shared their stuff, and we got to learn a lot of cool stuff there. So now we're applying everything into this whole company we're working with. So the game we're developing is called Farkeep. And Farkeep is like a retro-inspired but a modernized take on the old Zelda games. And like a phrase we have to say like for it is do you ever wish you could recapture the magic of the old Zelda games today? And Farkeep brings back the adventure, the charisma, and the pixel art with a higher visual fidelity and modern gameplay. So we're sort of modernizing it all. I'm just gonna let this play a bit. I think I have sound. Can I play sound? No sound. Okay. So yeah. But anyway, so the sort of ideas and inspirations we have for it. It started out with, Farkeep. We started developing it back in 2016 after we met at the Leo Game Jam. Me and Bjorn met, and we started like talking, and I pitched into him like, hey, we should make something a lot cooler than you can just make on a game jam. And he was like, yeah, okay, that sounds amazing. Yeah, okay. So then we started, working on these ideas, started iterating, prototyping. But Farkeep, the game we're working on, is inspired by Link to the Past, Undertale, Hyperlight Drifter, Hammerwatch. You probably know Link to the Past, that's Zelda. And then another thing that we are very passionate about is user-generated content. Because like one of the reasons why I am here today is because I really loved the Warcraft 3 map editor back in the day. Started making like mini games and stuff, playing with your friends, all that cool stuff. And it was like a period in when I was in like mid-school that I didn't buy a game unless it didn't have a map editor. Unless it did have a map editor. So so that's sort of like a thing that we have felt like, okay, games today, they don't ship with map editors anymore. So that's a thing we're very passionate about. We're going to put our tools in the hands of the players when we are releasing our game, so they can also create their own cool adventures and share with their friends. And then this engine we're making. So everything is, I started out in RPG Maker, which is a very like easy, basic type of engine. It's really fun to make stuff in. It goes really fast, but you can't make something advanced in it. And when you sort of like get stuck, you can't go on any further because the source code isn't available to you, and all that stuff. So it feels very dated, but it's very fun. And that's sort of what we took with us when we started developing Candid Engine and the world editor with it, that we're going to put in the hands of the players. It's like we want to make it fun and easy to make levels for it, for the game. But anyway, all these things I've said, it's not really like something unique for the genre in terms of the selling potential of the game Farkeep. And in the apocalypse is a fact. So how do we stand out with this game we're making? Now, you already seen footage of it. You're probably guessing like what we're going for. But a new idea. So when we started Farkeep, we had like basic 2D, and it was very inspired by Link to the Past graphics. So it's very like flat. But a thing we sort of like reason about is that when we look at this 2D map, it isn't 3D, it's just flat, it's just pixels. But we can reason quite easily, how this would look in a 3D environment. And same with here, like it's very easy for us to like see, okay, well, if I was in this game world, if I went down and looked from Link's perspective, I would see the house in like a 3D manner. It's quite easily reasonable for us to, reason that way. So we thought like, okay, how can we make sort of the computer think in the same way? And if you look at the whole perspective we're working with, it's called orthogonal 2D top-down. And so this is the camera, and a very important aspect in this case to keep in mind is that the wall and the top of a cube in this world would take up like the exact same like camera space. So in this case, like the camera's view is just flat on. So in that case, this side here, this one, and the top here, this one, takes up the same amount in the camera's view. So it can be like, you have to like think of it in that way. But we can make 3D in that case, matching up with the pixel art, given that we work in this orthogonal perspective. And with that, we can have 3D shaders. We also get nice collision data if we can, extract the 3D geometry out of it instantly, And we also get volumes, which is nice. And this is exactly what we did with our engine. So here you see footage of our world editor we have. So we start out with a flat map here. And now I am extruding like geometry from the flat surface. And a thing to note here, there isn't textures. It's just a projected texture down. And I'm just making 3D that matches up with the texture that's projected from the camera's perspective, which is this orthogonal flat top-down. Now get in water, some volumes. We'll get some cool scenes. And it's also really nice to like try flex around with, light, and also how fast it goes to just place stuff. And you can play it instantly. You can like see what you're making, and it sort of becomes like Mario Maker but Legend of Zelda. And here are some beautiful stuff. Okay, but now I'm going to talk about the reason why we made the game engine. And first I have to start at what is a game engine. And I think a lot of you probably already know, but for everyone else, this is relevant. So most people probably think of Unity and Unreal. So a game engine in definition-wise is like a software framework for making games. It's important to emphasize the making game aspect because there are other software frameworks, and software frameworks generally are levels of abstraction. You might think of .NET in case you're working with C#. I don't know why you wouldn't use .NET if you're working with C#. I don't know if you can, but .NET provides you with a framework. So you don't have to like worry about how the operating system implements the ability to save a file and load a file. .NET fixes that for you. So it's a level of abstraction for you. So that's a framework. And a lot of people probably also use it to describe the development suite utilizing the framework. So if you have the Unity game engine framework, then when you see like their development suite, you might think like, okay, that's the engine. But I would like to sort of separate. This is the development suite for the game framework, and then you got the Unity game framework, which is the engine that, that runs the whole game. So what does this game framework abstract usually? So there's a content pipeline that you don't have to worry about loading content. It fixes it for you. Sometimes you want to go in and fix it, maybe in Unreal, but usually you don't have to. Then the rendering, in very basic terms, is about displaying stuff on the screen. And you got input management, handling player input. You got different controllers, hand controllers, mouse, keyboard. It fixes it for you. You also got game scene management, which is loading and unloading game worlds with game objects in them. And then you also got spatial partitioning, which is a very important aspect in terms of optimizing, because if you're doing like collision checks, you don't want to do collision checks across the whole map or across the whole game scene. You would like to just check like the nearby geometry, so you don't have to sort of check for collision everywhere. It will be very costly to do that. And yeah, as you said, collision detection. So do geometries overlap or not? Well, and then also sound management. That's really nice to sort of don't have to worry that the music keeps on playing after you hit pause in the game development suite. And then you also got stuff like serialization and platform-specific code, which I won't get into. But anyway, so why did we develop a custom engine? This sounds like a lot of hassle. There's a lot of stuff that needs to be done. Well, first of all, we had to implement new technology because this is a new idea we had. But it could still be done in Unity. We had to make tools, though, for ourselves, because in order to work with this new technology, we've got to make tools that are fast and easy to use. Otherwise, it would be a big headache to work with this technology. But, we could still make it as plugins in Unity or Unreal. So then we got optimization, though. So when you compile with Unity or Unreal, you get a whole package of stuff that you might not necessarily want, but which is necessary to run the framework or run the game engine. Well, we could just hire an optimization consultant down the line. It's very costly, but, that's what a lot of indie studios do. Now, this one here, You might be like, if you're a game developer yourself and you're working in Unity, Unreal, you're making a big complex game, and then you sort of like play through it, and then at random points it like crashes, and you don't know why. We don't have that problem. We know why it crashes because we wrote the source code down below. No, but so a thing like if you find like a bug with maybe the rendering pipeline, in our term, like we're working with new technology here that sort of goes in the whole rendering process, and if there's a bug there that is hidden from us because we don't have access to the source code at Unity or Unreal, then maybe we'd like say to them, hey, you got this bug here, can you fix it? They're like, yeah, okay, well, we'll release a patch next year. And then, so that because now it starts to become like a risk management thing. And then you also got the revenue aspect of it. So Unreal takes 5%, and Unity is very costly for, development licenses. So in terms of in our case, it become like, it sort of boils down to risk management for us. Now, it's really fun as well, I must agree, to make an engine. But it sort of goes down to risk management in these cases. So, creating the Candid engine then. We're calling it the Candid engine. And I'm going to go through the components of the game engine. So first off, you had the input management aspect. And this is going to be in terms of how we solve like these components. So we got input management, which handles keyboard, mouse, controller input, etc. You got the content pipeline, handles like streaming file input output. You got sound management, which handles play and pause sound, expose sound API for designers, etc. You got the rendering pipeline. Probably it implements like the DirectX or OpenGL, maybe Vulkan and even Metal. Then you got collision detection or physics. Only collision detection in our case. We don't need physics. Spatial partitioning and search. And that's an optimization standard just to have it like as it is. And as I say, yeah, it divides the games into smaller parts. You got game scene management as well, and also an AI component. And so these four up here, what these like, how we like to categorize these four is that they all sort of handles with low-level components. Like this one implements DirectX, OpenGL, Vulkan. Now it isn't really low-level. I mean, like some professors at the university might say, the C language is a high level of extraction. But in terms of like what we are working with in C#, .NET, then this becomes very low level. And same goes for sound management. You sort of have to work with the sound card and the sound driver. The content pipeline, okay, how does the operating system it's running on handle files, etc. You got input management as well, like when is a key pressed, when do you release it? Do you have like events for when you're like tapping or repeatedly pressing or holding, So there's a lot of like low-level stuff you got to handle. And say it goes for like all of these types of controllers that I've listed here. So all these four are very low level, and we didn't want to handle those. So we are working in a framework called Monogame, which is a framework for C# and .NET. And Monogame handles these three for us. So it like has its own like low-level implementation of all of this. So we don't have to worry about them. And then we use the Fmod for a sound engine. So Fmod handles the whole working with the sound drivers, etc. And it's all of these four are cross-platform, so we don't have to worry about them now, because you shouldn't reinvent the wheel unless you absolutely have to. Someone else has already solved all of these like APIs and interfaces for us, so it wouldn't make sense to not use them. And then, the world editor we use is made with VPF. And then we just like put the whole game inside of VPF, and then you have a game editor, easy. Before we used Tile, our previous solution was Tile, which is like a tile placement, third-party program. It's open source, really nice. I think it's pretty much an industry standard for pixel art games. But as I said, we had to make new technology, so we couldn't really use it. And now it's going to go into a little bit of more like some principles of designing a game engine technology-wise. And some of you, I might lose some of you here. There might be only code programmers who enjoy this now, but tag along. So, the game scene management aspect. So, Oh yeah, all right. A thing to say. Yeah, so these four we had to like solve ourselves, but they are not low level. But I'm gonna go into the game scene management aspect, because that's a thing I see some like people who just make a simple game in like C#. They sort of like skip the whole engine part. You just want to like make a simple game and etc. And a thing to think about if you're gonna have many complex scenes is this: that data-oriented design is much better than object-oriented design in terms of speed and performance. That's because of a thing called data locality, which I will go into. And the most common solution in that case becomes an entity component system, or ECS. That's the same thing that Unity uses. It's also a good solution for particle system as well. But I'm going to go into just what this means. So if we have like, let's say, we set an n for max entities, which is 300 in our case. In our engine, it's 300. All right. So now I'm going to go through some example for each like type of entity we have. So this is the player, this is enemies, bandits, we got trees here, and also bushes. And I'm going to go into like how the sort of architecture looks when you're developing an ECS. So in our case, we have a general component which tells the system, the world manager we have made, that this entity should be handled in the scene. So this object exists in the game scene. And as you see, I colored all of these green because all of these components have this component to them. And this is an array that goes up to 300 in our case. So it's an array with a length of 300. And then we got the AI manager that handles all of the AI components. And in our case, these don't need an AI component. So we set a flag on it that says this entity does not have this component. But these three do. And then we have a collision handler that handles all the collision components. And in these cases, all of these have collision set on them. The bushes, you can walk through them, so they don't have any collision. And then you also got the combat handler. Everything that has health has it, which is only the player and the bandits in this case. Then you also got the aggressive component for aggro range checks. And the player doesn't get aggroed, only the bandits do on the player. And a thing to say then is because in these cases, we allocate memory for all of these arrays. So it's just like these arrays are saved in memory. They are just stored there, and we just say like turn off like these components for them. And that just says like, okay, well, when this combat handler just steps through here, comes here, it's like, okay, now I don't need to do anything, I don't need to do anything, but it still like has to check each like entry. And you might say, okay, isn't that like, if let's say we only have 7 entities on the map, isn't that like bad optimization to sort of have to go through all of these arrays all the time, and we have to allocate memory for them all the time? And the answer is no, because of a thing that's called data locality. And arrays give great data locality under the right circumstances. We can talk more about that, but no. And data locality is basically that the next sort of like relevant data when the CPU is executing something is just really close in terms of in the cache memory. So it just has to like continue executing on the cache. It doesn't have to like stop and then like in a linked list. If you make like a dynamic linked list, it has to like stop, maybe get something from the RAM, and that takes a lot of time. And this is sort of why, I mean, like probably only programmers will get this. And yeah, great data locality means very few cache misses, which means super fast. And more speed, you can go even further with these. If you divide an array between CPU threads and you can run them in parallel, you might have 1,000 entities. You have 4 threads, and you put 250 entities on each thread. Well, then, the longest time it takes is 250 entries. So that's speed up. You can also have, you can even go further with dynamic entity array size with heap memory and all that stuff. But I'm not going to go into that. And another principle you want to make sure with all of these systems you have now, so you have world manager, AI manager, collision handler, combat handler, aggro range checks. You want to abstract them away with APIs, application interfaces. And it reduces bugs, it's easier debugging, And it also adds the possibility for scripting support in the future. And it's also mental ease because now John can't screw this up. All right. I hope this was sort of clear. But anyway, the necessary knowledge you're going to need, if there's something like you feel like you're lacking, you might have to take that in before you jump on working on an engine. Proficiency in your programming language of choice. I don't think that's going to be a problem. But this might be linear algebra. If you feel a bit rough or you don't know about it, you need to check it out. You also got Newton's laws of motion you have to know. And also checking computer graphics and probably one of these four you need to sort of have like, because you're going to write shaders, you're going to need to know like how you communicate with the GPU and you sort of make everything efficient. And also this one is a big one, design patterns. You want to like look up some design patterns before you like start with a new system if you're going to make like a combat handler or something. Because choosing a suitable design pattern for a system from the start saves a lot of time and headache down the line. And these are like, this is a decorator design system, for example. There's many, but so I would really suggest on looking those up before you start because yeah, you're going to save a lot of time on that. So to summarize, game engines are software frameworks for making games. They usually follow a data-oriented design over a object-oriented, which you might think. But yeah, data-oriented, and they take a lot of time to make, definitely. There are good solutions for certain areas available to you already. In our case, we use Monogame for the content pipeline, and we use Fmod for the sound engine. So you have to like look those up so you can save time. You know, don't reinvent the wheel. Don't make your own like date system implementation. That would be insane. You need knowledge within math and computer science. Those areas I suggested. You can learn those as you sort of like go. You just go like head on, and then you sort of like explore the knowledge as you go. But if you can sort of like prepare that this thing will sort of like this issue will pop up in the future and I can prepare for it, then it saves you a lot of time in that case. So, but you might ask, okay, is it worth it? In our case, yeah, it was. It really is. It's really efficient. It's really fast. It goes really like developing goes really fast. And as I said, like we can find all the bugs in like no time because, as I said, we made the stuff and the engine the source code is available to us. And also, yeah, it might be monetizable in the future, which would be cool. In your case, well, you have to decide for yourself. Like, if you're making a AAA game, probably you shouldn't make a game engine. Or if you're making like just like a AA game or something like that, no. Or 3D game from the get-go, no. Unless you have a lot of money, or you just want the challenge. All right, thank you so much.
Great presentation. What is the status of the game engine? Is it
of the game engine?
Yeah.
In terms of
yeah, is it finished? Yeah.
Yeah, the game engine is finished, and we're using it to develop the game.
Yeah.
But if you're asking, like, is it finished for general purpose?
Yeah.
No. There will be a lot of more work necessary to sort of like abstract everything, because there's some connections still like to the game engine code you want to abstract away before you allow people to.
Yeah.
Oh.
But one day?
One day, absolutely.
One day,
yep.
Yeah.
That's the goal.
Yeah. We have a couple of questions here from the audience. Wouldn't it be easier to use a hash map or dictionary to allocate the game components instead of using multiple arrays for each new functionality, such as AI, collision, aggression, etc., etc.?
But sorry.
Yeah.
Can I see?
You can see here.
Would it be easier to use hash map dictionary to allocate the game components instead of using multiple arrays?
For each new functionality,
no.
yeah.
I can only like relate back to like C# on that case, but I suppose it's like he means like a dynamic hash map, and the dictionary is dynamic as well, or if he means like each like dictionary entry is like a new component.
Yeah, maybe we can. Yeah.
Oh, so
basically to have each, for example, instead of having a long array and having, for example, 1 to 3 is these characters that can be aggressive, you can just have dictionary and instead of having the entire new array.
Yeah, so that's the thing. Like, if you use like a dictionary, that's or a hash map in C#, those are dynamic. You know, it's like reference based. So when the computer goes to one element, you sort of have to look up the memory reference to the next element in the dictionary, and that's the thing that like can cause a cache miss, because in the dictionary. Yeah, that's how it goes. So that thing, when it has to look up the reference where it is, that can cause a cache miss because it can be anywhere in the memory. If you have an array, it's like guaranteed, like you have, this is the first element, and that everything after it is gonna be next to it in memory. So that's like the powerful thing about it. So that's why those dynamic like data structures are bad for in performance wise. I mean, they are nice, but.
Yeah. Great, you sorted it out. Yeah. Another question. At what point did you figure out that making your own engine was the correct way for you to go?
When it was the correct way, I think it was when I went in, like we went into our neighbors. We sit at East Sweden Game. We have offices, and we share offices with other game developers. We went into their office and was like, "Hey, what are you doing?" And I was like, and then they were like doing something. Like they wrote something in the script, and then they jumped back into Unity and pressed play, and it took 20 seconds to start the game, and we were like, "What? What? Well, how can you work in this?" So that was like, we decided like, okay, the frustration of having to, like that's sort of like the first step. But then we like realized like all of these other aspects, like, okay, yeah, well, now that we're making our own engine, we're not gonna have to optimize. We might not even have to optimize anything, you know, because it's so bare bones. But optimization is gonna be a lot easier. There's not gonna be any bugs hidden from us, and we don't have to pay Unreal or Unity anything. So we like discovered these like good things along the way more. But in the beginning it was like very emotional during like 20 seconds to compile this game. What? Sorry?
You don't have that kind of patience.
No.
No.
Definitely not. Not when developing.
So it will be something else with your game engine. Yeah.
Yeah, it's instant. You just press it and it's like,
Yeah.
you know, you can hot reload in Visual Studio and then you just press play and instant.
Yeah.
It's really nice.
That's great. You had a list in the end of your presentations of things that are good to know. What sort of walls have you hit into during your journey? I think it was on the previous
walls.
slide. Yeah, I mean like vad var det ni själva inte kanske hade koll på? What you yourself didn't know.
Oh
back
yeah.
then.
So like one of the problems we did in the beginning was that we did object-oriented design for the scene management, which we realized like when we had like I think we added 100 enemies, and then it was like starting having issues because there was like all of these aspects running. Yeah, like a dictionary in the beginning. So each like there was a string, and then you had the entity, and the string was like the entity ID. But now, you know, the ID corresponds to the position in the array instead. But that's how we did in the beginning, and that's when we realized, okay, this is lagging. And then we looked up, we found Jonathan Blow. He talked about like data-oriented design and how they solved you know, old games for the old consoles because they had super slow memory, or there was like really long distance from the CPU to the RAM. So they had to do it like that way, and we realized, okay, this is the way. And we realized that's how Unity does it as well. So, you know. Yeah. And that was sort of a wall we stepped into and learned a lot of. It didn't become a wall. It's like it wasn't impossible. It was just a roadblock. Yeah.
Yeah, and you passed it.
Yeah.
What reactions have you had on the game and also the game engine?
We've gotten a lot of like good comments about the game. It's like, okay, it looks really cool. When you light a fire, it sort of lights up the whole environment. It's not just a flat 2D shader on top of the screen. So it feels like it's really good immersion. That's sort of a thing we hear a lot. It's very good immersion, and it's really fun to like mess around with the 3D and stuff. But then, of course, investors. If there's ever like a senior person or investor type guy, he's like, well, it's really cool you're making a game, but why aren't you not just selling the engine, you know? And then it's like, okay, yeah, well, we started like here. The passion is for games.
Oh.
We wouldn't have an issue sort of focusing on the engine later on, but we sort of have like this like goal. We need to finish the game. Now we also like when we show the game to the game engine to other game developers. Yeah, I mean they like it, and they really enjoy the whole thing. That it's fast and it goes real fast. You just press play and you go. There's no need to recompile or anything. And they like the whole, the editor and everything. Very RPG Maker inspired.
Yeah. So what are your plans for the future, nearest future?
It's to release the game, release the editor with the game, so players can make their own adventures. And then, we'll see. We have plans for a second game after that, after Farkeep is released. We also have like plans on how we can make the engine, like maybe start beta testings, maybe start, getting other developers in, sharing the technology and stuff. So it's, but yeah, right now, the game.
Yeah.
Number one.
Wow. Thank you. So, are there any more questions out here? No. Not really. Well, thank you, Samuel. It's been really interesting. Although, yeah, you lost me on some of the slides, but yeah, I knew that would probably happen. But still, very interesting, and I must say I'm impressed by what you're doing. And I guess there are many more in the audience here who feel the same way.